Hello everyone, good morning. It's me Robin Koirala. Today I am here to present on the topic of analysis of solar and wind hybrid system for powering charging station of electric vehicle in Nepal using Homer software. This project is done for the course Electrical Power System and the project supervisor is Dr. Mohsin Jamil. In this presentation we will cover the introduction and objective of the project, and we'll also discuss the literature review methodology, and then we'll discuss about the site location with the available resources on each site, and we'll talk about the load data with the system description and each component description. Finally, we'll talk about the result and conclusion of the project. Now let's first start with the introduction. As you know that the population of the world is increasing day by day, the transportation industry is becoming much more wider each day. Transportation presently stands for around 61.5% of the oil consumed annually. This is a pattern that has been developed since 1950s and reports for roughly 29% of the planet's overall energy need. As one-third of the total energy demand of Earth is consumed by the transportation, it generates about 27% of the greenhouse gas, which is very significant in number. If this goes on increasing, the Earth and the living organism in it has very dark future. So as the solution, different EVs are being introduced in the market. Mainly, it has zero impact on the environment, and the cost of energy to run the EVs are much more lesser than the internal combustion engine, and are in decreasing trend due to the introduction of other energy resources. The transition will only be more meaningful and fulfilling if the power used to charge the electric vehicle also come from renewable resources. So in this project, a hybrid wind and solar power EV charging station feasibility study is done in country Nepal. Talking about the objective, to evaluate the performance of the solar wind hybrid system with grid connection in country Nepal is the primary objective of the project, whereas the secondary objective are to assess the hybrid energy power system economically using the Homer software, to observe the effectiveness of the conventional grid powered EV charging station in different locations of Nepal, to encourage the utilization of renewable energy for transportation. Now let's discuss about the literature review. Similar studies are done in different countries. The literature review table consists of 6 different papers in which the feasibility of powering the charging station with different energy sources are done in 6 different countries. Different studies are proposed in each paper, such as grid plus solar plus wind, grid plus solar plus biogas, and off-grid and on-grid connection with different renewable resources, etc. Studying all paper, it was revealed that the combination of the renewable energy to power the electric vehicle makes the project economically, technically, and socially efficient. The remarks are also shown in the table. Now let's discuss about the methodology of the project. At first, I collected the various paper and conducted the literature review. Then I considered the unique place for the project to select the site or the location of the project. After that, I did the estimation. I did the load estimation by considering the electric vehicle flowing and the traffic of the busiest city. Then after, I used the Homer Pro software to make the block diagram of the proposed system. Furthermore, I did the simulation, and finally I obtained the result and conclusion of the project. The figure 2 shows the map of Nepal showing 4 different locations, which are the major cities and the project location. The first one is Pokhara, the second one is Bharatpur, the third one is Kathmandu, and the fourth one is Biratnagar. The table 1 shows the coordinates of each location and the altitude. Now figure 3 shows the monthly average wind speed, solar radiation and temperature of all 4 locations. As seen in the wind chart, the Biratnagar experienced more wind than other 3 locations which has similar wind pattern. Whereas talking about the monthly average solar radiation, all the 4 locations have similar pattern of solar radiation. And finally, talking about the temperature of each city is different, and it goes on increasing from while traveling from Pokhara to Biratnagar. Now discuss about the load data. The EV charging load is assumed hypothetically considering the current EV density in the street and the peak hour of operation of Nepalese market. The charging station is assumed to be open from 4 am in the morning to 8 pm in the evening. The peak time is taken from 9 am in the morning to 3 pm in the noon, where the charging load is assumed to be 30 kilowatt per hour, and the remaining time the charging load is assumed to be 20 kilowatt per hour. The daily average charging load is taken as 410 kilowatt hour per day, whereas the peak load is taken as 54.1 kilowatt hour, 1 kilowatt, and the load factor is taken as 0.32. Figure 4 shows the daily, seasonal and yearly load profile of 4 cities for charging EVs. Talking about the system description, figure 5 shows the block diagram of proposed system. In the system we can see I have created 2 bus, AC and DC bus, in which the grid current and the current from the wind turbine is connected to AC bus, and the electricity from the solar panel is connected to the DC bus. As the load is also connected in the AC bus, so I have connected the converter to convert the electricity of the solar panel to the AC and supply to the load. Storage options are not considered in the study because the excess energy generated from the renewable sources will be sold back to the grid. Now about the components of the project. Canadian Solar Max Power Polish solar panel is selected in the project, which has a lifetime of 25 years. The panel has up to 16.9% efficiency and use PID resistance technology to enhance the system performance. Panel capacity is about 325 watt, which costs about 185 each and has replacement cost of $180 and operation and maintenance cost of $10 per year. The panel has a slope of 27.67 degree and a cell operating temperature of 45 degrees Celsius. EO25 class 3rd wind turbine having an output rating of 25 kilowatt is considered in the project. The wind turbine has a rotor diameter of 15.8 meter with a cut-in wind speed of 2.75 meter per second and cut-out speed of 20 meter per second. The hub height is taken as 23 meter and it has a lifetime of 20 years. Electricity from the grid is considered in the project, where renewable energy are unable to supply the demand. For this, the simple rate are considered, which are provided by the local electricity authority. The purchase of electricity from the grid cost around $0.071 per kilowatt hour, and the sellback price of electricity is taken as $0.055 per kilowatt hour. For the purpose of converting the direct current produced by the solar PV to the alternating current, the CAT BDISI 3PS converter is considered in the project. The converter has a lifetime of 25 years and has an inverter and rectifier efficiency of 95.80%. The per kilowatt cost of the converter is $800, whereas the replacement cost is $700 and operational and maintenance cost is $10 per year. After doing the simulation, the results were obtained and the table 2 shows the result. Table 2 basically shows the comparison of the conventional grid with the proposed system in all the locations. The net present cost, the cost of energy, the operating cost, and the initial capital are same for conventional grid in all the locations. Whereas while adding the wind and solar along with the grid decreases the net present cost, cost of energy and operating cost as shown in the table. Comparing the data of the four cities, it can be clearly seen that the proposed PV plus wind plus grid system was more beneficial in Biratnagar city and less efficient in Pokhara city. Figure 6 shows the hourly data of each location representing the power generation from renewable sources and power required for the grid. The blue and the orange color represents the power generated from solar and wind respectively, whereas the yellow color represents the power extracted from the grid to power the charging station, while the renewable energy are unable to supply the energy. And the gray line represents the load power in each time. These figures look similar for all the location, but the Bharatpur and the Biratnagar cities have generated more electricity from wind. Now let's discuss about the conclusion and recommendation of the project. In compared to grid-only system, the suggested wind plus solar PV plus grid system is able to reduce the net present cost, cost of energy and operating cost by around half. The utilization of only wind and solar PV was not viable due to the limited wind and solar resources in the specified cities. Adding storage was more expensive in the system, thus net metering was explored, which is more cost effective. In the future, sensitivity analysis can be performed to improve the accuracy and reliability of the results. These are the references from where I did the literature review and rather gather the information needed for the project. Thank you very much everyone for your time and consideration.